Tonight we're going to be looking at Model View Controllers, or MVC, and how we can use it in our computer science program. So the reason we want to look at this is, why are we talking about MVC? The idea of MVC, or Model View Controller, has a bunch of different reasons why we actually want to use it. The first one we have is the idea of organizing our code. One of the biggest problems we see with our code in general is that code can get quite messy and very unstructured. That's even if we're using a good object-oriented program and, even if we're using a good object-oriented structure to our code in our program, we can still get very messy code because of the fact that we send information from one class to another. We're not getting our stuff very well designed. And so the MVC structure helps us organize that code into a much more cohesive unit that we can actually have some good ideas and good structural ideas of computer science, such as cohesion and coupling. The second idea on that is the idea of the structural paradigm. This paradigm of Model View Controller helps us organize and understand the ideas of what actual our components do, how they relate to each other, and what they're supposed to be doing when we actually write them. By having the structure built in as we actually put our projects together, we can actually do some really good stuff and have our code look really well. Finally, the idea of why we should use MVC is it's a fairly professional approach. It is one of the main paradigms in use right now for actually doing programming or development, and the idea that it keeps with the idea of object-oriented programming, that reflecting the real world, and with MVC we have that same reflection of what's going on inside the real world as we actually put our code together and put our projects together. And so that's why we're going to be using the MVC structure with the code we do here in class. So we want to actually look at the components that are involved with MVC, or Model View Controller. Again, we have those three major components: model, view, and controller. And the model is where we actually put the objects that we are using in the project itself that we create. So this is, say, for example, if we're doing a project about, say, spaceships, we'd have our different spaceship objects in our model package. These are all the things that are created by you. So in the case this is something, say, for example, used by Java, like an array list or some other things that are built into the language, we would not put it inside our model because those are features that already exist inside the language or the program itself, and those don't need to be inside our model package. The view specifically is what the user is going to be seeing. So all the stuff that we are going to be having with interactions with the user itself will go inside the view package. And finally, the idea of the controller, and this is where the director of the film, this is also where we see the things that start and interact with the user. This is where we send messages from one component to another, because the controller goes behind the scenes and plans out what's going to happen and directs the action itself within the program. Now, specifically, since we're using Java in this class, we're going to use some Java conventions for this. One of the first conventions we want to address is the idea of designing first. We want to plan our code out. We want to decide what's going to happen, what are the pieces going to be, what are the parts that we're going to use for this actual program itself, and that goes along with the same standard idea of object orientation and object decomposition. Also, since we're using Java, we have the idea of a package structure. Remember that a package in Java is simply a folder within our project itself that holds all of our code together. And so we're going to be using that package structure with the MVC, where each individual file that we have, where each individual package, model, view, and controller are subsets of the actual project itself. Inside the project itself, we'll have three packages. We'll have project.view, project.model, and project.controller. And those three packages will hold all the files associated with each of their individual subcomponents, the pieces that go inside the model, view, and controller respectively. Starting off with design, we need to identify what this project needs to do. So this is a great time to do some brainstorming, identify the parts of your project, what's going on, what's going to be happening, and how we think it needs to work itself out, what the relationships are going to be between the different objects. After we've gone through and identified that basic brainstorming session, we want to start now looking at the actual nouns, verbs, and relationships between those nouns that we have identified. The nouns are going to become our objects themselves, and we can identify from those relationships we see if there's a component relationship on that. The objects will have data members that are instances of those other objects, and we'll identify some of the collections that might be needed, etc., and get those ideas and those representations put together. Then after identifying those objects, we can start identifying the methods, doing the idea of the decomposition of the methods, what needs to happen when, and how it needs to happen. And we'll start identifying what return types will be used, how many parameters will be needed. After looking at those ideas a little more closely, after we've gotten the basic design of the objects itself in place. And so again, with the design step, we first want to brainstorm, identify those main components, get those objects identified, and start building the stub classes for them. Then once we've got those classes designed, the basic form, we start identifying the data members and the associated methods that go along with them. and then we put them together in more detail. Again, keeping the same principle of making sure our code works all the way through and building them up piece by piece. Looking at our model. The model is designed to reflect the real world. This is where all of our pieces are that we're using inside our project. Of course, all of our project is going to be designed and written by us ourselves. However, the model itself are the parts of code where you're creating an object and you're using instances of that object inside your project. So if we're doing a project again on spaceships, this is where we put the Millennium Falcon object. This is where we would put the battle cruiser object. This is where we put the spaceport object. All the pieces that we build, that we design, that are specifically designed for this project itself. The collections inside those objects, say for example, the fuel level inside the Millennium Falcon, the number of slots available to park spaceships in the spaceport, these are things that would be completely, that are using built-in language type devices such as an array list or an array. And those obviously don't need to be made inside the model because they're existing components within the language itself. This is where we also are going to specifically have quite a few of our getters and setters and any specific construction ideas that we need to have when we build this. Again, we want to make sure we identify all those basic components, identify the data members that belong to our objects, and get the getters and setters that are attached to them fairly early on so we can then call them as needed inside our code. Well, that again happens after we've done our basic design and identified those relationships, saying that, for example, a spaceship has an engine. What type of engine, we identify those components and get those built in as needed, or stub them out if we don't need a lot of detail to them yet. With our model, these components will change every single project. Our model objects are going to change all the time. So if your spaceship project will have spaceship objects, your robot project will have robots in it, your healthcare project will have, say for example, medical records in it. Your model components are always going to change every single project. So you don't look for a big set of consistency in here. Your model is going to have different things every single time. Again, looking at this, when you refine your design, these are the major nouns that you have identified as components within your project, the things that you're talking about, those big ideas. This is what goes inside our model area or our model package. Looking at the view, this is what the user is going to see. Now, since we're using Java, a lot of the time we're going to be using the GUI for that, using a JFrame and a JPanel or collections of those, or we might even, oh my gosh, use the console. We might have to talk vis-a-vis the keyboard and using just the regular command line input. Now, for some crazy reason, design is also important here. We want our buttons and our fields, etc. to put together in a way that makes sense. So simply throwing them together on the screen is probably not the best idea. We've been using in class most of the time the spring layout where we can actually organize our component pieces of our view, how we want them to look, and that way we can actually design and make them place in a nice organized fashion. If you're using some other layout, say for example a grid layout, you want to make sure that you add those in a method that will actually make sense, where your actual setup layout method that inside your panel will have those added to it so it can actually keep those in a nice organized fashion. Otherwise though, make sure when you're putting your view together that it makes sense. If you're using a console view, obviously you're going to want to have a way of actually interacting with the user via the console that makes sense, probably having a good text-based menu so you can interact and go back to that menu as needed. Our view components on the GUI side, we're always going to have a class that extends JFrame. The JFrame object is the part of the GUI that's going to control the actual view of the code. It has that lovely big red button in one of the corners, whether it's Mac, Linux, or Windows, but it's going to have that big window itself where we actually close the application. And when we create this object, we're going to pass a reference to our controller object as part of that. Because by passing that reference to the controller, we can send information from the view to the controller. We can manipulate the information within our project. We also have at least one panel inside our project when we're doing Java GUI. Our JPanel, our class that extends JPanel, is going to have all of our buttons, fields, etc. that we're going to be using and have any fields or display parts that we'll have set up. And that's going to often use the controller. So not only will it have the controller passed, it will have a reference to the controller as an actual component within its design. And again, with the event panel, this is where all of our visual components are going to be seen. The panel is going to have all of our pieces inside it. Looking at the controller a little bit more detailed now, the controller is what's going on behind the scenes. It's where all the action is happening. This is where we're going to see everything happen, where the controller is going to send information that the user clicks on. It will catch that information from the user, send it to an appropriate method within the controller itself, manipulating the models and or other components, performing calculations, etc., and then sending information back to the user. So it's kind of like a middleman. It's going to be taking information from the model and passing it to the user, or taking information from the user and passing it to the model, and vice versa. That passing information back and forth and controlling the calculations, etc., is where we're going to see a lot of our actual code and more of our functional programming happening. This is where all of our methods are going to be. There are more than simply just getters and setters. This is where we're going to be manipulating information, changing information, creating objects, and using them as needed. Our controller is going to have a couple parts that are always going to be there. The first is going to be our runner. Every project needs a way to start, and so that is going to be our runner class. Our runner object will always have within it a public static void main, and inside that PSVM we're going to always have a reference to whichever app controller we're making and its start method. That class is going to be a boilerplate set of classes. It's always going to look the same. We'll see some examples later on here in our next lecture. But the idea on this is that the controller itself is always there. The runner always is in the controller because it's one of those actions it performs, and it's by itself, so once we have that written and standardized, we don't have to worry about it happening ever again. And the next class we're going to have inside our controller is always going to be our app controller. And this controller object is what's going to own the GUI. It's in charge of passing information specifically from the visual component to the model back and forth and doing any of the calculations that need to happen within that. So app controller is going to be specifically for that project, so the name on it will be, say, for example, the spaceship app controller or the medical parts app controller. It's going to have a reference to the actual project itself and its name. It's going to own the GUI for that project, and it will send a reference to itself to the GUI, so information can pass from the GUI to itself all the time. And again, also it will have object instances of the model objects that we're using, or ability to make more objects so it can build up and manipulate that information as needed.